Hi, today's video we are going to deploy our trained model to AWS SageMaker. From previous video, we built automated ML workflow. We assume that you compared all the different model versions and now you determined which model to be production. It's time to deploy your model to REST API. Today's session, we are creating the Airflow deck, which changing the model alias to the production. In the next task, we trigger the GitHub action workflow. We build custom Docker image for model with model serving logic. Then we create a GitHub action workflow for deploy our ML model to AWS SageMaker endpoint. Without further ado, let's get started. In the Airflow deck, transition model.py, we create default argument in the Airflow deck task and task dependencies. Then we create the logic for our callback functions. We go to script and model training. We go register. We create one function here. Then we create one folder called model deploy. Inside we create package.py. We import this libraries and create this callback function and import. To explain the functionality of this stack, first we import our libraries, import default argument, and then we define the deck named transition model to production. And also at this moment we set schedule interval at once. We're gonna change this later. So within the deck, we define two tasks. First task is the transition model to production, and then second task, which trigger GitHub action workflow. We specify the task dependency here. The first task, and then first we define the model name. We get the MLflow tracking URI from environment variable, and then using that tracking URI we set the tracking URI here, and then we also get the MLflow client. The first stage, we need to find existing production version model that has production alias, and then we need to change the alias to archived. Also, we set the current production model tag to archived. Then we can keep track of the previous production model. We get the model version with staging alias using this method, get model version by alias. We get staging version here. Then we validate whether the staging version exists or not. Then if the staging version exists, we assign this one to model version. Then using this one, we change the model alias to the production. Also, the set our the model tag also status to the production. After we change our alias from staging to production, after that we need to make sure that this model that doesn't have a staging alias anymore. So this one is the double ensuring we log our detail by using the update model version. This version we provide this description here. So after that we retrieve run ID from our production model, because we used the staging version to change to model version, so This one is our new model version with production alias. So we got this, our production run ID. And then we get the run, we get the artifact URI here. From there we get model URI. So after that, after we got a model URI, we need to validate whether our model URI exists. After that, we send our production model version as well as model URI. This logic is important for deploying our model by using GitHub action. So with this one, we can dynamically deploy our new model version through the GitHub action. We execute this one, trigger GitHub action. In this function, we'll try to get model version and model URI from previous task. And then we set the model name is identical to the previous one. And then image tag, we using the model version we got from previous task, and then we create a tag with model version here for image tag. We get GitHub, our GitHub repository token. Also, we get the GitHub repository name. Then we using from the variable from Airflow, we already set GitHub token and GitHub repo. And then after that, we dispatch the URL. This one is we are sending the request through this URL to the GitHub repo, our target GitHub repository. To send the request, we need to set the header, the authorization. We need to send the token of our repository using barrel, and then accept. This one is the VND GitHub JSON, also the contents type. This one you should follow your guide documentation. And then after you define headers, and also you need to define the payload, what information you want to send. We need to define two. First one is event type. So we need to define the types of event. We define the name here, MFlow prod triggers. If the GitHub receive this event, then the GitHub workflow will be triggered. We need to define this one. And also in the payload, we need to send the information that needed to trigger our GitHub action workflow. So first one, we need model name. The second one, we need model version. And then third, we need to send the image tag. We need to send the model URI. That is most important. Using this one, we need to send the post request to this URL using this header and the payload. And then once we verify that whether response is success or not, so wait for the response, and then if response is 204, then we can generate the log. If we got a status other than 204, then we can log the error that we failed to trigger the GitHub action. Yeah, so this is the logic for in the Airflow side. After we train the model, then we transition our model to production. As soon as we change our model version to the production, then send the request to trigger our GitHub action. So this is the logic from Airflow side. So after that, we need to deploy our model. We need to create the logic to deploy our model to SageMaker using GitHub action. We need to create our GitHub repository. Deploy SageMaker video. Create repository. Then we clone this GitHub repository. You need to build custom Docker image with the serving logic here. Then we need to push this repository to our GitHub. After that, we can create the GitHub action workflow. So first we need to create Docker file here. Inside, create from github.io. This repository, this you can find in here. The MLflow official documentation, you can see, you can find this repository has the pre-built MLflow image. So using this GitHub pre-built MLflow image, first you need to run all this the Linux command that installs all these packages, all these dependencies. Download the miniconda here and install miniconda, and then we set the environment path. We need to install the miniconda to execute conda environment, to execute and activate our conda environment. After that, to install our AWS CLI in here, download, and we unzip and we install AWS CLI. After that, we remove. So after that, we run pip install. So after that, we copy the SageMaker, the subbing logic here, also the entry point to the Docker image. We give a permission to be executable, the port that container use. Also, we set the SageMaker environment variable here. We set the entry point here. So this is the logic for the Docker file. And then next thing we need to do is we need to create a SageMaker subbing logic and entry point sh. To do that, we also need to create one file here. Here we import all the libraries and we define app using the Flask to define the inference logic, get model, prepare input, get prediction, return output. All this logic for the inference. Need to define the model path. Try to get our model using this model path. And if you go to get model we defined earlier, we using the OS join the model directory we got from here, and then we join with the model.pickle. This is the name of our model, and then we open model path, and using the pickle package we load this model, and then after that we return our model here. So this is getting our model. And then there is a simple logic that the API URL we get using get method and the slash ping, and then inside it's just a simple whether that model is known, we return the error. If model exists, to send the response to 200 says we have a model. The main logic here is this one. When you send a post request to this endpoint, and then through this URL invocations, you will receive the input data for inference. So we get a first Flask request get data, and then we got a request body. Then after we got a request body, and then we try to get the XY. To do that we are using the prepare input logic that receives request body and contents type. So contents type we validate here. So if you go to this logic, we are actually preparing data. If we're validating that the contents type is application JSON format, if not, we're gonna raise the error. If contents type match to the application and JSON format, then we try to load data by using the read JSON, because our request we send the data through the JSON format. So from request body, we are loading data from JSON format. So we got a data. We transform our the y variable, which is the delivery hours, to log transformation. Because of the training logic, we prepared target variable by transforming the log transformation. And then after that, we only select source data set for training. We set our timestamp data to datetime object. After that, we set the timestamp to the index, and so we have a datetime index. After that, this is the feature using predefined the column names. We only select the features for x, the delivery hours log variable for target. So we return the xy value here. We are preparing inputs for model inference. So after we prepared the inputs, we need to do the prediction here. So if we defined get prediction function earlier, and then if we go here, and then the logic is very simple. We got the input data from previous function, and also we need to get the model. So using this model, we call the predict method by using the x, and then we generate the prediction value. After that, so we need to reverse back to our original format by using the exponential function. We got a prediction value here. Then if we go to the return output, to do that we need to convert our data to the JSON format. To do that we need to use JSON dump y prediction. We need to y prediction to list. Also y true we need to change to list. Also when is the prediction time. This is preparing the JSON format of the output. But I made one mistake that because the y prediction we give the original format from the log transformation, but the y true is not transformed to original format. So I need to do this one. I will return the same output. I think the logic is not really that makes sense because we unnecessarily need to transform our target variable, also reverse back to original scale, but it's not really the target variable is using. But anyway, maybe this logic needs to be enhanced in the future. But anyway, we are returning the same format for y true value and y prediction value here. So we are returning, we prepare output for JSON format here, and then after that we return using response, using the output here, status 200. This is very simple, the REST API. Anything go wrong, we respond to error. Lastly, we need to add this one, the main function that app runs. Yeah, so this is the simple inference logic. Also, we need to create one file called we create this one. Why we need this logic to execute our Docker file? Because our model is dependent on scikit-learn or the packages. In the artifact store, we have the conda YAML or Python env YAML file. That is to run this model. We need this the dependencies. So we need to install this dependency, and we need to activate the environment, the virtual environment, to use our model. To do that, we need to execute this logic. We need to check whether the conda YAML file exists in the model artifact. Conda YAML file, we check whether the file exists. We generate the message that we found the conda YAML file. Then we create the conda virtual environment here by using this logic. Name the model.env. but this one is model mlflow.env. It doesn't really matter. And then we activate the virtual environment we just created here. We can use our the model without any error. After that, we can execute our server. So by using the gunicorn, the gateway, worker, timeout, and then by using the SageMaker serving logic here, so we are executing the Flask server by using gunicorn, the gateway. We prepared all this logic. The next thing we need to do is we need to push our files to our repository. We can see all this file in GitHub repository. And then next thing we need to do is we need to go to action. We can find any templates here. I will say the name to deploy to SageMaker. Default is on push or on pull request, but since we are sensing the event from Airflow, we change this one to the repository dispatch and types MLflow prod trigger and run on Ubuntu. We need to set the environment variable here. Environment variables, like we need model name, we need model URI we got from Airflow, so we can get from the Airflow GitHub action trigger task. We can receive the model URI. Then role ARN. This one we need to create our role, SageMaker role, to access our SageMaker service in AWS. Also, we need to define the endpoint config name. We need to create the SageMaker endpoint config first to create endpoint. After that, we can also specify the SageMaker endpoint name here. In the steps, we need to, this checkout code means we are fetching our GitHub repository to Ubuntu machine, so we can build our Docker image here. And then before we need to install some requirement. We need another requirement .txt file. We need to install the MLflow and Boto3 to use the MLflow command in Ubuntu machine during the action workflow. The next step is we install requirement file txt. After that, we need to configure AWS credentials, because we need to log in to our AWS CLI. To do that, we can action marketplace AWS, configure AWS credential. Then if you click the use latest version, then you can see how to install. We copy this one. So after install, we log in AWS credential, register your access key ID in the GitHub secret is ucenter1. Then you will be fine to log in to AWS CLI. After you log in, you also need to access to the Amazon ECR. To do that, we also need to use our existing action from GitHub Marketplace. So if you go, then you can see below here Amazon ECR login action, and you can add this command. So you need to use this one to log in to the AWS ECR. So once already you have the access key ID and access key, secret access key, and you authenticate the AWS from previous step, you don't need any further steps to give the access key and secret access key of any ECR. The next step is you need to install Docker step build x, docker setup build x. This is the action to install docker build x before you building your docker image. Then you can install and set up build x. Now you can build the docker image. So build docker image and push docker image to AWS. To do that, we also need to give an environment variable. This variable, you can get the registry name. Also, the repository is MLflow, so I can get this image tag from Airflow. If you are building the Docker image in Mac OS, the platform should be Linux and AMD. The OCI media type false to ensure that the Docker image we build should be compatible to deploy in AWS SageMaker. We also specify push true, set this repository to be used in the next task. That's why we need pipe here. The next logic is delete our existing SageMaker model. So this step, we are deleting existing SageMaker model if there is a exist, or if not exist, we by using this one we are passing to not generating error. If there is a existing SageMaker model, if we don't delete this one, the workflow will be failed. So we are ensuring that we are deleting existing SageMaker model with the same name. And then after we delete it, and we are creating a SageMaker model. We are creating SageMaker model by using the MLflow SageMaker push model command to deploy the MLflow model to SageMaker. We need to change our model format. Format is pickle, but the SageMaker require different format. So we need to convert our model format to tar. That is required by AWS SageMaker. Model name here, we need to provide model name here. Also model URI, the SageMaker execution role ARN. We need to make sure we create this one. I will show you how to create later. Also the model URI should be the address for the S3 bucket. And then after that, the bucket name. After we convert the model format from pickle to tar, we need to save our model to the new S3 bucket. So we need to create another bucket. The name is package model for SageMaker deploy. This is an additional bucket we need to create. The image URL that required by to creating our MLflow model through this step, right? So we're using this image URI here, and then region name. Then you can create the SageMaker model. So to execute, we need this one, execution role ARN. To get this one, we already set in here, but the for those of you who setting up this one for the first time, we can go to AWS console. Then you go to Amazon SageMaker AI. You can go to Amazon SageMaker AI here. You go to role manager, create role for user, persona. Next, you can configure new roles here. Click additional, use MLflow. I will skip it here, and then next, review your role, and you can submit. If you go to the IM, if you go to roles, then you will see MLOps video. You will see here, and you can see there is a ARN here, and you can copy and paste your role ARN here. But I'm gonna use my existing one. There is one issue, whether your user, your IM role have access. You only have a S3 access. So another thing you need to do is you need to modify your role to be used in your IM role. This one can be used by your user. So to do that, you need to edit your policy here. You add this one, assume role user. This user, the IM user, you created this one, MLOps video. Then you have your own the ARN here. So you can change to this one, update policy. User you just created able to use your role that you just created. You need to do one more step, and you can go to policy and create policy and JSON like this resource. So you're creating policy that action is state assume role, STS assume role. Then you need to specify your the role here. So you copy your this ARN you just created, and then you attach here. And then next, your policy name, this one, you give a policy name here and create policy, and then go back to user, and then add permission, allow assume SageMaker role video I just created. We see this one, and then next add permission here. Then you will see that you will have the assume role that you can access to this role you just created. So now you will be able to access this role. You have a permission to this role in the MLOps video user to create your SageMaker endpoint, and then how to attach this role to your IM user. So you'll now be able to create your endpoint through GitHub action. But at this time I will stick to my previous role because this one is attached by our access key ID and secret access key. So then you got your execution role ARN here. The next thing you need to do is creating new bucket. If you go to S3, then you will see the bucket name, package model for SageMaker deploy. Inside you will see that model.tar.gz. This format is required by AWS SageMaker, so you need to create one S3 bucket and then specify your bucket name here. Yeah, so this is the steps to run this command, mlflow SageMaker push model command. And then by using this command, you're creating your SageMaker model from here, your model pickle file, and then you'll convert the model format to this one can be deployable to AWS SageMaker. They will use the image we built to create the SageMaker model. Next thing you need to do is deleting the existing endpoint configuration. After you create SageMaker model, then you need to create the SageMaker endpoint configuration. Deleting existing endpoint configuration ensure that there is no existing endpoint configuration with the same name. We are creating the SageMaker endpoint configuration by running this command. And then give a endpoint configuration name here, the configuration specification, and you're giving a model name here. You give the instance types of the endpoint. We are using ml.t2.medium. We are adding these steps. First, we are deleting existing SageMaker endpoint. This is the same reason why we are deleting the existing endpoint configuration. We are making sure that there's no same existing endpoint. We need to delete existing endpoint to avoid the workflow failure. After that, we are deploying the SageMaker endpoint using this command. using the endpoint name, using the endpoint, the configuration name here. When you created the endpoint, it will take some time to endpoints to be the in service. So this is the waiting. The endpoint will be in service, and then after that it will finish the workflow. And then we'll commit the change here. And if you go to the repository, you will find that there's a new folder here, GitHub workflow, and then inside you will see the name, but you can change the name here. Inside there is a YAML file that define the oldest workflow. And also I need to mention that how to set the environment variables in GitHub action. Like, even though you set those environment variable, the first one is you need to set this one, AWS access key ID and secret access key to be used. You need to go to, if you go to your repository here, your repository, you go to settings, the secrets and variables, action. You can set the secrets here, new repository secret. Then you add the secret after you create it, and then you will use this one. You will access your information through this one, secrets dot your key. So in my case, I will show you my existing the repository. So I set my repository secret by using this key. So by setting this one, you can access to your variable here. Also, another thing I need to mention, to trigger GitHub action in Airflow step, I set the Airflow variable. To set this Airflow variable, I import this Airflow variable here, and then I set this variable through the Airflow UI here. So if you go to the admin, you can see the variable, provide GitHub token to here, and GitHub repository. Once you set these variables in here, you can use it when you're running your task. Since our model can be trained by using my existing pipeline, I will demonstrate how to deploy to SageMaker. So to do that, the transition to the production trigger GitHub action is identical. So I will manually trigger this one. This is the same as I showed you before. So this is the existing one. If I go to the model here, previous video I triggered my automated ML workflow. The model pushed to model registry with the staging alias. It's time to change alias to production to deploy our model to AWS SageMaker. I'm going to trigger this step, the production, and then we trigger the GitHub action. So after that, version 30, we change to the production. And then if we go to the repository here, and then go to action, then now you can see that the workflow now running. We go to build. All this job completed, success. Then if you go to AWS console and SageMaker AI, if you go to the inference, then if you go to models, you will find the model named delivery delay model soul. You can see that all this information, that is the image URL in our ECR repository. Our image tag built using our model version here. So 30, if you go to MLflow, yeah, you can see the model version 30 used to build the image container. And also you can see that the model location in S3 bucket. Also, if you go to endpoint configuration, you can see there is a endpoint configuration that was used to build our endpoint instance type here. Then after that, if you go to endpoint, you can see there is a endpoint status in service. If you click, you can see all this status, the endpoint URL. So let's try to the inference. I will use newest data here, the new data from Postgres, from feature delays. Then I get the newest data frame that is newest in KST. And then I need to convert this one to JSON format here. Then I got this one. I copy all, and then if I paste it and then send the request, then again the request to the endpoint, I got a 200 OK response. Then in response body, you can see the Y prediction, Y true, and the time here. That is what I expected. So if I let's say schedule the automate model training workflow, maybe let's say every day, after align our Airflow automated model training and transition model to production, and then GitHub action will automatically deploy the model to endpoint based on the schedule. Yeah, this is the end of our video. If you like the video, please subscribe, like, wait for the next video. Bye.